Hello everyone, today for the PHY351 we are going to discuss about the glass and its role in optics and imaging.
So I'm going to start with history of glasses. First, historical origins. For tools and decorations, early people employed glass that was found in nature, such as obsidian. By polishing quartz and other clear materials, the ancient Egyptians and Mesopotamians produced the first lenses around 2000. These served as burning glasses or magnifiers to concentrate sunlight. Glassmaking process were investigated by the Greeks and Romans. Roman glassmakers experimented with refractive characteristics and created rudimentary lenses. So next is medieval developments. Development of reading stones, convex lenses construct of glass were the earliest known optical devices known as reading stones and were used to magnify text for the blind and visually challenged. Islamic contributions. Al-Hazin and other scholars developed optics by examining lenses, refraction and reflection in his groundbreaking book of optics. So third is the early modern era and the Renaissance. The 13th century saw the invention of spectacles which improved vision correction by mounting glass lenses in frames. Development of microscope and telescope. Galileo Galilei and Hans Lippershey invented the first glass lens telescope. By employing ground glass lenses to view microorganisms, Antony van Leeuwenhoek transformed microscopy. So next is the revelation in science. Understanding refraction, achromatic lenses were created to lessen chromatic aberration in telescope as a result of Isaac Newton and others' investigations into the laws of light and optics. Production of optical glass, the development of superior optical glass made it possible to craft lenses with greater accuracy. So now we move to innovation in the 19th and 20th centuries. 19th century's photography. The development of photography fueled improvement in lens technology and the production of specialty optical glasses. Refractive index control. With the advancement in glass compositions and lens coating, chemists and physicists such as Ernst Abbe and Carl Zeiss transformed optics. Industrial production techniques made cameras, binoculars and telescope widely available. Next is the modern era. Fiber optic. Glass fiber were created for imaging and telecommunications which transformed endoscopic imaging and data transfer. Development in glass technology made it possible to employ lasers in imaging system, manufacturing and medicine. As photography moved from film to digital, optical glass for cameras, telescope and microscope continued to be improved. So lastly is current trends and future direction. Modern glass incorporate nanotechnology, adaptive optics and metal materials for imaging system in fields like astronomy, medicine and augmented reality. Researchers are developing eco-friendly glasses and coatings to reduce environmental impact.
There are so many glass applications that we could think of in our real-life implementations. First, lenses. Lenses are tools that widely used to improve our eyesight in particular way, such as single vision lenses, bifocal lenses, trifocal lenses, and progressive lenses. Second, mirrors. Mirrors are reflective coatings on glass. They are widely used in optical systems. Third, optical fibers uses transmission of light signals in telecommunication and medical endoscopy. Fourth, windows and prisms control light direction and wavelengths for scientific and industrial purposes. There are so many other applications that we could think of, such as in medical field, such as optical instruments like microscopes, and also in display technologies such as OLED and LCD. For example, camera lenses have the precision glass lenses that focus light to capture sharp images, and also corrective lenses made from glass can improve our vision. Second, mirrors. Mirrors have the reflective telescopes that have large glass mirrors that reflects and focus light from distant stars. Rear view mirrors are used in vehicles also for the visibility. Third, for the optical fibers, fiber optic cables are used for high-speed internet and data transfer. The endoscopes can also deliver light and capture images inside human body. This is used in medical field. And last but not least, windows and prisms. Laser window is a protective glass window that allow laser light to pass through, and prisms are used in dispersed or refract light in spectrometer and binocular.
So next, we move to role of glasses in optical and imaging. First, lens material. Glass is widely used to manufacture lenses because of its predictable refractive index. Second, glass lenses focus light onto a sensor or film in imaging system, enabling the capture of clear image. Secondly is transparency and light transmission. High quality optical glass is transparent and allows a broad range of light wavelength to pass through with minimal absorption of scattering. This is crucial for the transmission of clear image and accurate color reproduction. Glass provides excellent transparency with minimal distortions, ensuring that the light reaching the imaging system is clear and undistorted. Third, steadiness and accuracy. Glass is strong and able to hold its shape over time, which is crucial for lenses and other optical devices that must remain accurate in a variety of environmental circumstances. Because glass can be produced with such great precision, it may be used to create optical components and finely tuned lenses that need precise tolerance. Fourth is coating. To improve the transmission of light and reduce unwanted reflections, lenses are often coated with anti-reflective films. This coating helps reduce glare and enhance the clarity of image. Glass lenses are often coated with crash-resistant layers of UV protection to prolong their lifespan and maintain optical performance. Optical fibers. Glass fibers are used in fiber optic cables to transmit light signals. This is important in applications like endoscope, telecommunications, and high-resolution imaging systems. Glass fibers can carry light over long distance with minimal loss of signal quality. Lastly, prism and filters. Glass is used to make prisms that bend and split light into its component colors or change its direction. This is important in spectrometers and optical instruments. Glass is also used to create filters that can block or transmit specific wavelength of light, which is useful in photography, microscopy, and other imaging technologies.
So the next part is advances and innovation. For the first one is smart glasses, for example, virtual reality, augmented reality, and Google Glass, which is a mini projector that displays onto semi-reflective mirror. It will provide 3D image focusing on micro-LED and photolithography process, which helps the efficiency of lens collection. The second one is camera. For example, smartphone camera, which is one of the development of various point-of-care diagnostic tools. It will bring a high quality of image that utilize the field portable endoscopic due to the fiber optic fluorescent imaging. Light will transmit through object that sampled by a fiber optic array. So the next one is benefits and advantages. The first one is transparency, which is optical glass can provide an accurate diagnosis for disease prevention that give a high performance imaging in microscopes and lenses due to wide range of wavelength. It is also a cost effective. The second one is advanced technology. It used in the camera lenses and smart glass as I mentioned in a previous slide. It is also propose a low cost and compact digital array. Also, it will provide a sufficient sensitivity and specificity, which is projecting a spatial resolution on micrometer scale. So the third one is fiber optics. Fiber optic will provide an accurate diagnosis and high performance imaging in microscopes and lenses due to a wide range of wavelength. The last one is purity and durability. The optical glass produced by direct melting raw material of high purity resulting in high homogeneity with precise refractive index. Also, it has a strength resistance and unbreakable due to sufficient mechanical characteristics and high chemical durability.
Now, let's move to the challenges and limitations. Firstly, glass is brittle and can break or shatter under stress. This is a challenge for portable devices like cameras, microscope, and telescope. To address this, we often use a protective coatings or robust housing, but this will add weight and cost. Secondly, glass lens, especially larger ones, are heavy. This is a drawback for mobile devices or lightweight cameras, where portability is key. Reducing weight without compromising quality is a difficult trade-off. Other than that, producing high-quality optical glass is expensive. Precise grinding, polishing, and coating are required to achieve the needed optical properties. This makes high-end systems like telescope and medical imaging devices costly and less accessible. Lastly, glass expands and contracts with temperature changes, which can alter its optical properties. In precision application, this can cause misalignment or image distortion, requiring careful thermal management or alternative materials. Now, let's move to the future trends. Firstly, new glass materials with enhanced properties are transforming optics. These include tailored refractive indices, lower dispersion, and greater durability. Future impact: better optical system with sharper, more accurate images. Innovation like photonic crystal fiber and nanostructure glasses will improve light manipulation efficiency. Secondly, 3D printing of glass is gaining momentum. It allows for quick, cost-effective production of custom optical components. This will enable prices, bespoke lenses, and complex multi-layered optics that were hard to produce before. Furthermore, to meet the demand for portable devices, lighter and more durable glass is being developed, often with composite materials. Future impact: Cameras, smartphone, and AR devices will become more portable while maintaining optical quality. Hybrid glass plastic material could also reduce weight without compromising strength or transparency. Lastly, smart glass can change its properties in response to stimuli like light or electricity. This technology enables lenses to automatically adjust focus, light transmission, or shape in real time. In astronomy, adaptive optics can correct atmospheric distortion, providing sharper image from telescopes.
In conclusion, as a fundamental component of scientific and technological advancement, glass has revolutionized the domains of optics and imaging, from prehistoric lenses and reading stones to contemporary fiber optics and sophisticated imaging systems. Glass has allowed people to investigate the microscopic and macroscopic worlds, transforming disciplines like photography, astronomy, medicine, and communication. Glass's special qualities, transparency, refractive ability, and chemical engineering adaptability make it essential for creating instruments like cameras, telescopes, microscopes, eyeglasses. Glass continues to lead the way in optical and imaging innovations, holding up the promise of even more improvement in accuracy, effectiveness, and use. This lasting relevance emphasizes how important glass is as a material and as a catalyst for advancement in technology and human understanding.